Greetings, Earthlings. Today I want to talk about the future of math education, a simple proposal. I deliberately want to make this a question mark because I don't have all the answers. I think I have a lot of good ideas. I know a lot of other educators have a lot of good ideas, but I wanted to kind of package this in a simple way just to kind of get a discussion going, and rather than getting lost in the weeds, just put out the basic sort of tenets. Hopefully it's a little bit provocative, but not for the sake of being provocative. Okay, so in a nutshell, and I'm trying to really simplify this, I'd be happy to talk hours on length, maybe interview format or, Q&A with to go into more depth. Okay, currently, here's the math system that I'm familiar with in the US and many countries of the world. We have 12 years of math. That is the key thing I want everybody to focus on. So that's not sort of unusual. 12 years, some might be a little bit different, but roughly 12 years of math, first grade through 12th grade. And the result, let me give you my finest artwork. Here we go. That is the result. Let's talk about very quickly what are the positives, and then we'll talk about the many, many, many negatives. So the positives are I'll just kind of list them out. We still have mathematicians, engineers, scientists, even after the process that we have that has many, many problems with it, there are still people that go into mathematics, engineering, science, technical fields, or society still has not broken down, but so that's sort of, you could argue that we've come this far with that system. So you have to give some credit, like it's done something. Okay, now just because something has worked doesn't mean it's worked very well or you couldn't have done a lot better. For example, I could scrub a bathroom floor with a toothbrush and I'll get the job done eventually, but that's not the best way to go about it. Here's the main concern I have. This splits into different groups. On the one hand, let's split this into like 80% of the population, 20% of the population. So 80% of the population probably did not need most of that math. I know math teachers, we love math. There's all sorts of cool applications. But if you ask somebody, like, how much of that are you using in your daily life? The vast majority, I'm just throwing these numbers randomly, but most people will not use the majority of that math. Furthermore, the 20% that do use it, like of that 20%, of this whole bucket, it's more like people that end up being good at it are the exception, and it's like despite the system, not because of the system. So my question is, if you've done something for 12 years, I expect you to be pretty good at it. That's kind of the thing. Not just 12 years, but how much time? So 45 minutes a day in class, let's say 5 days a week. Like somebody should do the economics of this. How much? So 5 days a week, 12 years, plus let's say 30 minutes of homework. That's a lot of time students are spending where they could have been spending other things, doing other things. All right, so that's sort of the thing. The quality of that education for most students, they don't know most of it. They couldn't teach it to somebody else. Also, like the big thing for me is their attitude towards learning has changed. So like the quality is low. There's a lot of boredom, destruction of curiosity, etc. Right? Like I'm not going to go into all the negatives, but anybody that's ever been through a school system, the students right now and the adults, there's not just the students that are falling behind and don't get it. Like they're obviously struggling. The kids in the middle are bored. Like even the kid, I was one of the success stories doing high grades, going to elite institutions. I was deathly bored. I could have spent that time much better, done whatever I did with that 12 years of math in a fraction of that time. So this applies to all levels, whether you like math, you don't like math, it's your thing, it's not. Okay, what am I proposing in simple terms? Sorry if that took a while, I just want to establish that. I'm gonna make this kind of radical, but let me just throw it out there. So 2 years of math, and let me make this blue, and we are going to put a yellow smiley face to bias you guys to, that's not yellow, but we are going to propose this as the happier solution. Okay, so we have 2 years of math. What else do we have? Think about rotations. So, example, medical school. I would claim, and I don't want this to, I'm throwing out a number just to kind of put a stake in the ground, so this can be discussions. Don't treat the 2 years as like a rigid, like, oh, it's exactly 2 years and maybe it should be 3 years, maybe it should be 1.5 years. We're talking sufficiently less, like significantly less time than 12. So instead of 12, this is like a fraction, right? A huge fraction. For some kids, maybe it's a 1.5 years, maybe it's 3, whatever. So it could go at your own pace. It doesn't have to be 2 years for everybody. But I would argue that all the math that the majority of people, like the 80–90% that may not become mathematicians, engineers, scientists, all the math you use in your real life. And by the way, I made a video referencing this loosely, another future of education video, which you can find on my channel. So what sort of topics would we learn in those 2 years? Well, basic arithmetic, stuff like basic percent, basic geometry, like what is a triangle? Okay, a triangle has 180 degrees, that kind of stuff. Unit conversions. What are we not going to do a lot of in that time? So like in that 2 years, we're not going to do a lot of algebra. We're not going to do a lot of calculus. We're not going to do a lot of proofs other than some basic stuff, just so people have an idea. Okay, so you go to the store, and again, in the future, whether money's around or money's not around, obviously this would depend on the culture and the society, but I would argue 2 years is enough to make somebody culturally literate and functional in society for most applications that are not specialized. Now, let's say this is going to be for everybody, whether they want to continue and go into math and science engineering or not. One of the cool things that I think medical school does well is rotation. So instead of saying we're going to do geometry for a year, or we're going to do algebra for the next 2 years, or a year of calculus, we can have everybody do a quick rotation showcasing the highlights across subjects. Now, how long could this be? This could be anywhere from, I mean, you could be a day, but I'm just going to say a week to a month, something like that. It might depend, maybe like 1 to 2 weeks. It might depend on the subject, for example. So a very short time period. Like I said, this is flexible. It's more throwing out the concept of roughly 2 years, like cut out all the fluff, okay? Stop tricking students into thinking you're going to use algebra one day. Yes, there are contrived scenarios. Most people will never need it. Now, that said, I think everybody should be exposed to what this can do for them. So in these rotations, not only will they be fun because they're showing the highlights, the applications, all the stuff that makes mathematicians and engineers and scientists love the subject, but students are going to get to experience way more subject than they ever could have experienced. So like we're talking about topology, linear algebra. You don't have to solve these crazy linear algebra problems. You could just say, here's what linear algebra will do for you. If you have 25 equations with 70 variables, there is a way to solve that not by hand in a reasonable way. So those sorts of things, showing them some highlights will get students potentially far more curious and interested in the stuff without killing their love of learning. Now, after this period, we have our 2 years of math, rotations. I'll come back to that 2 years in a second. And let me just add the word 2 years of math. Let's call that like upgraded or something. But after this, let's say a student like really is interested in topology, or they want to learn algebra. A lot of students will want to learn these topics. And then this doesn't mean we revert to the old long-term educational model. It just means there can be well-developed paths. This is a little bit in flux because, again, students can learn through applications, being part of study groups or projects or research groups. But there can be a kind of well-trodden sequence of like, okay, if you want to learn this, let's just say for the purpose of this video, you could still approach this a little more traditionally, like learning algebra, learning calculus, learning topology. Let's say a student decides at this point, I'm not really interested in this the linear algebra. I don't want this algebra thing sounds pretty boring. I don't like it. They don't have to learn it. Now, they can come back at a later date and do the sequence. So the argument is, well, yeah, you'll need it one day. Like, I don't like deciding for students. So this is kind of, a lot of this has roots in like in-time learning and things like that. So the idea is this: you've exposed students to a lot of material that they can see, okay, you know what, I'm curious about geometry. So then they go into geometry. Or right now, I'm actually not interested in math. So maybe there are times, go outside, go read a book, go do some coding, biology, write a poem. There's plenty of other things they can do. So that would be kind of my general proposal. Instead of this, we have 2 years of math, followed by rotations to introduce students to many, like almost every math subtopic that, like by math professors and people that really know their stuff, showing the gems of math. Okay, now, one thing, like if you go to somebody with these 12 years of math and you say, okay, multiply 8 by 12. To me, this is part of this 2 years of math, like the basics arithmetic. Or let's say 8 multiplied by 24. This would be a good example. Go to the adults in your life, the students in your life, and do a quick poll. How many of, like, out of 10 people, how many can do this in 7 seconds? If you're in average company, right? Like I would say maybe 1 to 2 out of 10 people can do that in about 7 seconds. So to me, that is a failure of all of that. That is just one example of failure. So I expect students to be able to do this sort of small to medium-sized mental math calculation, even though like math is not just about number crunching. But my point is, even the basics, if you're spending 12 years, your basics should be solid. But everything is flimsy. It's like you've just dragged people through a 12-year exhibit and they're sort of battered by the end. All right, that's where I'm at with this one. Let me know what you guys think. So I'm proposing 2 years of math, get rid of all that time spent in just students going crazy with hours of homework. We can talk about the necessity or lack thereof of homework as well, but this is kind of radical. So this doesn't mean nobody does 12 years of math. It just means the students interested in 12 years of math can do 12 years of math. And I believe actually you might think, well, not as many people will get exposed, so the number of people doing math will drop. My prediction would be, and we can test this, the number of people interested in math and science and engineering will actually go up because we will not kill their curiosity. All right, lots more to talk about here. Catch you guys in the next video. I want to hear what you guys have to say. Take it easy.